Yeah, good evening. Java.util package classes and interfaces, how many categories divided? Without seeing the notebook. How many? Two categories. What is first one? Collections, framework collections. Second one? Legacy collections. Collections, framework collections means JDK 1.2 and above. 1.2 onwards. 1.2 onwards, collections, framework collection. Legacy collections 1.0 and 1.1. So 1.0 and 1.1 versions collection class and interface are called legacy collections. Okay. 1.1, 1.2 and above collections framework collection. Collections framework collections, how many subcategories divided? How many? 3. What are those? Core collection interfaces, general purpose implementations, more utility collections. Okay. Core collection interface, how many are there? 10. What are those? Collection, list, set, map, sorted set, sorted map, navigable set, navigable map, queue, deck. 10. Okay. General purpose implementation, how many are there? 10. What are those? Array list, linked list, hash set, linked hash set, tree set, hash map, linked hash map, tree map, priority queue, array deck. 10. How many completed? 5. Still 5 left. What are those? Hash map, linked hash map, tree map, priority queue, array. These 5 today we'll see. Now hash map. If the class name ends with diamond operator or angular brackets, that class is called generic class. What is K and V? Key and value. So here two-dimensional collection. Two-dimensional. Write it. It is a two-dimensional collection class. And it maintains key and value pairs. It is a two-dimensional collection class and it maintains key and value pairs. It is a two-dimensional collection class and it maintains key and value pairs. Next, it is an implementation of hashing technique with array representation. It is an implementation of hashing technique with array representation. It is an implementation of hashing technique with array representation. It does not allow duplicate keys. It does not allow duplicate keys. values may be duplicated. It does not allow duplicate keys. Values may be duplicated. It allows one null key and many null values. Why only one null key? It allows one null key and many null values. Values many, but null key only one. Why? If you think, you'll get answer. Answer is there only. In notes only answer is there. Duplicate not allowed, no. So two null keys not possible. Duplicate not allowed. Null also duplicate not allowed. Two null keys also not allowed. It does not allow duplicate keys. Null key. Null also one time only possible. Two times null if you write, that is nothing but duplicate, no? That's what not possible. So duplicate not allowed, that's what not possible. Next. It is an unordered map. It is an unordered map. Here, insertion order is not preserved. Initial capacity of hash map is 16. Load factor of hash map is 75%. So this complete information available in documentation part. Documentation, very depth will be there. That is not required. java.util.hashmap. If you type, you'll get it documentation. Here. See, hash map superclass is abstract map. Abstract map superclass is object. Okay. Here all implemented interfaces. These three interfaces implemented. These two subclasses. That information. See, null values and null key. It allows. Null values allowed. See, and permits null values and the null key. One null key only allowed. Okay. So here 0.75 load factor. 0.75 nothing but 75%. This is, you'll understand while teaching this one, lambda expression at a time. See, hash map. Initial capacity 16. Load factor 75%. Okay. Here what you can do, you can specify initial capacity. Based on that, again load factor 75% only. Here 16 allocated by default. Here if you write 10 only allocated. 20 if you write 20 only allocated. Like that also you can specify. Load factor also, if you want, you can specify here. If you pass collection directly, according to that, it will create. 4 constructors are there. If you use first constructor, 16 elements memory allocated. 75% if it is filled. So out of 16 elements, 75% means 12 elements. If once 12 elements are filled, next to 16 allocated. It won't wait until completion of 16. So first 16 allocated. In a 16 elements, 12 elements are filled. Again 16 elements allocated. That is called load factor. Because here what will happen is load factor, why it will not wait for 100%. Indexes required. No? Yesterday algorithm I given. Like the modulo division by 16. Like that, same index may comes again and again. In that situation, it is shuffled. That is the reason. Again 16 allocated. It won't wait until 100%. It won't wait. Next is 16 allocated. Here methods. Many methods are there, but it is 2-dimensional. That's what add method will not be there. See, add method not there. Here put method will be there. Put key value. Put get. Put get methods are there. 2-dimensional. Again remove method normal. Remove is there. Okay. These are the methods. Now these points only required for interview. These points only. See, will it allow null value or not? Will it allow null key or not? What is the initial capacity? What is the load factor? And the insertion order is preserved or not? These type questions only interview questions. Okay. Now, how to write hash map program C? How to write hash map program C? This is yesterday tree said. Now hash map HM equal to new hash map. If I write, now it is unsafe. Any type of key allowed, any type of value allowed. If this type hash map, if you write, whenever you compile the program, then immediately it shows one warning message. You have seen. It is unsafe operation, it shows. Java C demo.java. Like one element at least if you add, you'll get it. HM dot put. Like suppose if you write integer. See compilation. See you are getting. Demo.java uses unchecked or unsafe operations. Okay. Demo.java uses unchecked or unsafe operation. So in this class, in this program, this object is unsafe. Here any type of key allowed, any type of value allowed. If only one particular type of key, one particular type of value, if it is allowed, that is safe. Because I want to maintain employee numbers, salaries. Employee number, which type will be there? Integer type. Salary, float type. But one employee number, integer, one more employee number, other type will be there? Never. Total one particular column, one particular type only will be there. Okay. That is the reason generics we have to use. Like by mistake, what will happen? Suppose data entry operator, employee number, salary. While entering, by mistake, number place salary, salary place number entered, suppose. What will happen? Accepted. Accepted. That is, you can solve with generics. Okay. If you write generics, what will happen? If you type any other type, if you enter in that box, error comes. If error comes, he'll concentrate. If error is not coming means, he'll type so many mistakes he'll do. Okay. That is the reason generics. Say, data entry operator is going to enter like this. Data entry operator point of view, graphical user interface will be there. Employee number, salary is going to feed complete. Data entry operator is going to enter employee number, salary. Else write submit button. Suppose if preparing one statement is entering. Now employee number will enter, salary will enter. He'll click on submit button. Again employee number, salary. He'll click on submit button. Again employee number, salary. By time is salary, year employee number entered. If you write like this, it is accepted. Error also will not come. Accepted. Number plus salary, salary plus number. By mistake, if you enter salary plus employee name also accepted. Name also accepted. No? That's what. This is not safe. Now, first you have to decide which type you want to maintain. Suppose employee number, integer, salary, float. Now that is again specify here. Okay. Now employee number, salary. Suppose otherwise employee number, employee name. Otherwise name and salary. Whatever you want you can maintain. Whatever you want you can maintain. Okay. So employee number, salary, or employee name, salary. Let us whatever you want you can maintain. Suppose employee name. Name if you want to maintain string. Salary float. Now first column salary name. Second column salary. Like that only accepted. Okay. Now suppose year. Now suppose I'll add hm dot put. Suppose here employee names. Suppose I am writing Java developer names. Now James Gosling. Okay. Some salary. Let this I'll write. Okay. hm dot put. Like Ed Frank. Like this I'll write. Like employee number, salary. Year. Java members, total 5 members are there. So James Gosling, Ed Frank, Patrick Norton, Cherry Sworth, and Mike Sheridan. These all Java developers. Java, James Gosling, main person. Like this I given. Okay. See, if I print 4 plus 3, 7 digits, 7, 7, 7. No. See, system dot out dot println hm. Two string method called. See, file save. If I compile, see, no warning. That means it is safe. Java demo. If I enter, what you are getting? First Patrick Norton you are getting. Okay. First Patrick Norton you are getting. But what I written? James Gosling. Because it is unordered map. It is unordered map. But this order, how it is Patrick Norton first coming. That is yesterday one algorithm I given. No? That type of algorithm will be there. Based on that, it works. Okay. So again, this first letter P, ASCII code modulo division 16. Like that works. Okay. This is about hashed map. Write this one. Example. These all points over. No. Next example. Write this. put method for adding. In two-dimensional put method, one-dimensional add method. First write the program. How many elements memory located by default? 16. Now I entered 5. I entered 5. Suppose 12. 12 if you enter, up 16 only. When 13th one if you enter, what will happen? Again 16 allocated. 13th element comes no, then again 16 allocated. Like that. 75% if it is filled, again allocated. But array list 100%. After filling all, next allocated. Initial capacity of array list is 10. Load factor 100%. 100%. Okay. But has said hash map 1616. Initial capacity. Okay. Now. Is it over program? Now. Initial capacity of hash map is 16. Load factor is 75%. Okay. Now. Output we cannot predict. This output. This is an unordered map. Output we cannot predict. See first what is came? Patrick Norton. Next Cherisworth. Next Ed Frank. Next Mike Sheridan. Next James Gosling. Insertion order is not preserved. My order not maintained. Because inside hashing algorithm works. Based on hashing algorithm, output comes. Is it over? So this output we cannot predict. Like with algorithm, we can give answer. Hashing algorithm. Modulo division by 16. Reminder comes in that location stored. That is yesterday given like that. Next one, linked hash map. Is it one dimensional or two dimensional? It is also two dimensional collection. It is an implementation of hashing technique with linked representation. Will it occupy less memory or more memory? Linked means more. Why more? Nodes. Data stored in nodes. It occupies more memory because data stored in nodes. It does not allow duplicate keys. Values may be duplicated. It allows one null key and many null values. It is an ordered map. Here insertion is order is preserved. Initial capacity 16, same. Load factor of linked hash map is 75%. Is it over? It is linked hash map. But it is ordered map. Our order maintained, preserved. Whatever I'm going to give order, same order output comes. Is it over? See, just object creation I'll change. That's it. Here, just linked. Here linked. Okay. Now, this variable name same also you can continue. Otherwise, if you want LHM, linked hash map. Same name also works. Any name works. That object reference identifier. Now, same output comes. First James Gosling, next Ed Frank, next Patrick Norton, next Cherrysworth, next Mike Sheridan. File, save. See. Now, previously that is output. Now this is output. See. Now previously this is output. Now James Gosling, Ed Frank, whatever I given. My order maintaining. Okay. Write example. Now names are keys. Salaries are values. Here null key we can write, null value we can write. Names are keys. Salaries are values. Name place null also allowed. Value place null also allowed. But null key only one. Null values many. Because duplicate not allowed. Now my order only output comes. Whatever I given. Is it over? So collections framework topic is very easy, but these all points you have to remember. Program is nothing, you observe. Only adding, removing, inserting, updating, deleting, these only will be there. But interview purpose important. Whether it allows null or not, whether it allows duplicate or not, what is the initial capacity, what is the load factor, which technique used internally, that is they'll ask. Is it over? But if you write duplicate also, error will not come. It is ignored. Now here key value updated. That type. Suppose if I write LHM dot put, again James Gosling, if I write, will you get an error? Suppose like this are written. Now you will not get any error. See, file, save, compilation, execution. What is happened? Salary modified, updated. But James Gosling one time only showing, no. So if you write same duplicate, valid, but modified. If you write null, this is null key. If you write here null, this is null value. But one more null key if I write null, here 5000 if I write, what will happen? This null 5000 printed, latest one. See, file, save, compilation, execution. See, null 5000. But actually null I given. Duplicate not allowed, but it is updated. So initially null key contains null value. Later null key contains 5000. That means that salary updated. That type. That type it works. This is about linked hash map. Next, tree map. Tree map. It is also two-dimensional collection class. And it maintains data as a key and value pairs. It is an implementation of which technique? You can give answer. Yesterday you studied. Binary search tree technique. Which representation? Linked or array representation? Linked. It occupies more memory because data stored in nodes. Same. It does not allow duplicate keys. Values may be duplicated. It does not allow null keys. It does not allow null key. It allows null values. Key, null key not allowed. One key also not allowed. It is a sorted map. So here insertion order is not preserved. See here, it is hash map. Linked hash map is there. Linked hash map. Here also initial capacity. See, constructs an empty insertion order linked hash map. Default initial capacity 16, 0.75. Okay, but tree map it is not there. See, util dot tree map. On tree map, if you click, see here constructor constructs a new empty tree map using the natural ordering its keys, but they didn't mention initial capacity. They didn't mention load factor. That meaning empty created, one element comes, one only allocated, second element comes, second only allocated. That's what they didn't mention. Load factor also not mentioned, as well as initial capacity also not mentioned. You observe complete documentation. There is no initial capacity word. There is no load factor word. That means no load factor, no initial capacity. More than one is there. Load factor comes. That's what that is no need, right? Now write this one. These points only important. Program is nothing. Points only important. One collection, one type. If all same is there, why these all? If sorted list required, you have to use tree map. Your order required, you have to use linked hash map. Very fast searching required, you have to use hash map. Like that you have to select. Depends upon situation. The actual usage of collections after joining the company, you'll understand. Every day we use. Because these are huge amount of data is there required. Large amount of data while processing. Suppose example, today, how many users registered in Gmail? I want to find out. Lakhs of people will register. How many people logged in? I want to find out. Like that, lakhs of people will be there. That data, suppose today, total worldwide, how many people purchased one Nokia mobile or Samsung mobile or Apple phone. These all. This information if you want to retrieve, how much data will be there? Lakhs of people are buying per day worldwide. Crores of people will be there. Crores of transactions will be there. At the time, data processing frameworks we use. Example, Hadoop, big data. For that one also, this is required, core Java. For learning Hadoop also, core Java required. The prerequisite. So these collections every day required while developing real-time projects. The actual usage after entering into job, you'll understand. Without collection, there is no software. Without data structures. See, Windows operating system also with the data structure programs only. Windows operating system also developed with data structure programs only. Okay. See, tree map, these are the points. It is sorted. Suppose you observe, just I'll make it tree map. Now, while sorting, only keys are considered. This is same name also you can continue, other name also you can give. Now, which name comes first? Alphabetical order. Ed Frank. C. Cherisworth. First it comes. Next, Ed Frank. Next, James Gosling. Next, Mike Sheridan. Last, Patrick Norton. See, file, save. See, compilation, execution. See, Cherisworth, Ed Frank, James Gosling, Mike Sheridan, Patrick Norton. Alphabetical order. All right, this one. Example. Is it over? Suppose if I write null here, value allowed, but key not allowed. It will compile successfully. While running, null point exception comes. See, file, save. See, compilation, execution. See, null pointer exception. Why null pointer exception is, what will happen is actually, these all going to be sorted, no? While sorting, with null comparison problem comes. That's what it will not allow. Comparison required, no? Like while sorting, these all sorted automatically. While sorting, James Gosling compared with null. Null is not, there is no object. Then what it will compare? Comparison purpose error comes. Now, is it object or not? Is it object? No, it is not an object. Okay. Here object is there. Here object is not there. See, for example, string s equal to null. String s equal to, okay, s2 equal to null. These two same or different? Same or different? Different. What is the difference? In this line, object is there. Where is object? Null is object. Every string literal itself an object of string class. So it is object created here. That object referred by s. What s contains? Hash code. Here what s2 contains? Here what s2 contains? Null. No hash code. Object is not there. Object is there, hash code comes. See, here string object created. This object contains null. This is contains hash code like this. But here how it will created? S2 created. Here null will be there. So this is nothing but string literal. You study literals. How many categories of literals? 6. What are those? Integer literal, floating point literal, character literal, string literal, boolean literal, object literal. It is object literal. If object is not there, object literal comes. So there is no object. Then comparison purpose, James Gosling, if you compare with this one, valid, but with this one comparing not possible. That not allowed. Okay. This null here not allowed. Suppose here any other if you write, it is valid. File, save. If I compile. See, accepted, no? So null value accepted. Null key not allowed. Here null not allowed. Okay. Now here, next write it. Differences between hash map, linked hash map, and tree map. Differences between hash map, linked hash map, and tree map. Three parts. First hash map. Next linked hash map. Next tree map. It is an implementation of hashing technique with array representation. It is an implementation of hashing technique with linked representation. It is an implementation of binary search tree technique with linked representation. So hash map is hashing technique. Linked hash map also hashing technique. But tree map is binary search tree technique. But a hash map is array representation. Linked hash map is linked representation. Tree map is linked only. Here technique same, here technique different. These two representation same, here representation different. Okay. What is binary search tree? Yesterday explained, no? Binary search tree explained, no? What is binary search tree? If the element is less than root element, it must be left subtree. If the element is greater than right subtree. If the element is same, no, I don't accept. Duplicate not allowed. Okay. Yesterday explained. Now, here hashing technique. What is hashing also explained yesterday. That's what I didn't given, because yesterday hash set, linked hash set, tree set, same concepts. That is one dimensional, this is two dimensional. That's it. Same points you studied yesterday, observe. Okay. Here hashing, here binary search tree. Here array, here linked. That is first difference. Now, it occupies less memory or more memory? Less memory. This one, more memory. Third one, more memory. It occupies less memory, it occupies more memory because data stored in nodes. It occupies more memory because data stored in nodes. It is ordered, unordered, or sorted? Unordered. Unordered map. It is an ordered. It is a sorted map. It is an unordered map. It is an ordered map. It is a sorted map. While sorting, keys only compared. Value, associated value as it is will be there. This difference also you have seen yesterday. Same type. It allows one null key. and many null values. It is same here also. It allows one null key and many null values. Here it does not allow null key. And allows null values. These are the differences between hash map, linked hash map, and tree map. Over. Is it over? Next, hash set, linked hash set, or tree set. These three, one type. Here, hash map, linked hash map, and tree map. Okay. Write this one. One side this one, one side this one. Hash map, hash set, linked hash set, tree set. Hash map, linked hash map, tree map. First difference. These are one-dimensional collection classes. These are one-dimensional collection classes. These are two-dimensional collection classes. Second, these collections contain elements. These collections contain key value pairs. Okay. These collections contain elements. These collections contain key value pairs. Okay. Next. These all set map differences. Set map differences, same. These are index based collections. These are key based collections. Always key required. These are key based collections. Okay. These are key index based collection. These are key based collections. These collections do not allow duplicate elements. These collections do not allow duplicate elements. These collections do not allow duplicate keys. These are sets maps. So set map difference is studied, no? Same, no change. So in interview, if they ask what is the difference between hash set, hash map, same differences. What's the difference between linked hash set, linked hash map, same differences. Difference between tree set, tree map, same differences. Sets, maps. Is it over? Priority queue we'll see tomorrow. Next priority queue. Priority queue array deck. 2 more classes left. We'll see tomorrow class. Still 15. We'll see continuation tomorrow.